So the next problem we're going to try is 1024 in your textbook. It's on page number 357. I'm going to read out the problem to you. At t is equal to 0, a car with an initial velocity of 80 feet per second begins to coast to a stop as it proceeds up a hill. It comes to a stop in a distance of 500 feet and then starts to accelerate down the slope. Determine the displacement of the car at t is equal to 16 seconds. The magnitude of deceleration up the hill is equal to the magnitude of acceleration down the hill. Okay. So one important thing to note here is the question starts off by saying t is equal to 0. So you should not think of this t is equal to 0 as time interval, but rather as a time stamp. That means if you have a stopwatch, you start it. Just when you started, t is equal to 0. That's what it means. Okay, and then we need to find the displacement at t when the stopwatch reads 16 seconds. Okay, so the question is something like this. It's a hill. And the car, I'm just going to draw a box for a car. It reaches a certain height up the hill, and this distance is given as 500 feet. Okay, and what else do we know? 500 feet. The initial velocity u is 80 feet per second. Okay, so we know the initial velocity. We know. Yes. So with an initial velocity of 80 feet per second, it goes up the hill, goes up to 500 feet, and then stops. So it is decelerating. Okay, the acceleration is negative. And then it comes to a stop, so that means we know v is equal to 0. Okay? And then it slides down, and then at time is equal to 16 seconds, we need to find we need to find the displacement. Now, from the first part of the journey, which is going uphill, there are certain things we can find. We can find the acceleration, we can find the time it took to get there, because initially time is equal to 0, and then something happens, and then at time is equal to something, it reaches this point. Let's call this A, and let's call this point B. It reaches B. Okay, and then again something happens at time is equal to 16 seconds. We got to find a few things. All right, now you know that when s is given and when u is given, fps is feet per second, not frames per second, right? Okay. V is equal to 0. Using these three, we can use our formula v squared minus u squared is equal to 2as. V is final velocity, u is initial velocity, a is acceleration. In this case, it's going to turn out to be negative because it is decelerating. Okay, v is 0 squared minus 80 squared is 2 times a, we don't know, times 500. Okay, so we gotta find, what's that, 6,400, right, divided by 1,000, right? So a comes to, so that's negative, so a comes to 6.4 feet per second square. Okay, now we know the acceleration, or the deceleration, sorry, there's a negative here, deceleration with which it is slowing down. How long did it take to slow down? Because eventually we will need to know this time, right, when it reached v equal to 0, okay, or when it reached 500 feet, same thing. Okay, that formula is simple. What is the formula connecting initial velocity, final velocity, and time? V equals u plus at, or we have also written v minus u equals at. Okay, so from here we need to know the time is v minus u over t. So v is 0 minus u is 80 divided by divided by a, and acceleration was negative 6.4. So time comes to 80 divided by 6.4 is 12.5 seconds. Okay, so 12.5 seconds is how long it takes to get to the peak. Okay, how long it takes to get to the peak. And then after now it starts coming down. So here we know, I'm going to write it in a different color. So t is equal to 12.5 seconds at that point. Okay, now it begins to slide down with the same acceleration. It says that same acceleration as this. However, now it is going from 0 and the speed is increasing, so it will be positive, but magnitude is the same, and it tells you in that question that the magnitude is the same going downwards. Okay, so and then how much of a distance has it covered, right? How much of a distance has it covered as it comes down with this acceleration now? Okay, so downward journey. What do we know? We know that the initial velocity here is 0 because it went up and stopped, and it's coming down. How long has it traveled? Well, we need to know at t is equal to 16 seconds. That's when we need to know. But the time interval is not 16. The time interval is 16 minus 12.5. That's equal to 3.5. Okay, so remember, this is time stamp. Okay, and this is the time stamp. So it took this long to go up. Now at time equal to 16 seconds, that means 12.5 seconds are already over in going up. Now at time equal to 16 seconds means at 3.5 seconds on the way down. So t is equal to 3.5 seconds. Okay, v we don't know. Acceleration is 6.4 feet per second. Okay, feet per second. We need to find s. We need to find how much it has traveled. Okay, so we know the formula that relates these three. S equals ut plus half at square. U is 0 times t plus half. A is 6.4, t is 3.5 square. If you want here, you can write 3.5. Let's do that for the sake of completion. So 0 times 3.5. Okay. All right. So this whole thing becomes 0. So what do we get? Half times 6.4 times 3.5 square. Give me a second. So 0.5 times 6.4 times 3.5 square is 39.2 feet. Okay, so that is the displacement at t is equal to, at timestamp at t is equal to 16 seconds. Okay, so let's recap. So now we have understood the entire problem, we have solved the problem. Now let's kind of try to go back and replay it. At t is equal to 0, it starts from here. Okay, at t equal to 12.5, it reaches up to b, right? T is equal to 0, t is equal to 12.5, and then at t equal to 12.5, so here at t equal to 0, velocity is 80 feet per second. At t is equal to 0, the velocity is 0 Okay, and the distance it has covered is equal to 500 feet at this level. Now on the way back, t is equal to 16 seconds. It has traveled s equal to 39.2 feet. Okay, we can also find the velocity if you want. So we can say v equals u plus at. Let's do that just for giggles. V equals u plus at. The initial velocity is 0 because it is starting from here, with a 0 velocity coming down. Acceleration was 6.4. Time was 3.5. So what do we have? 6.4 times 3.5. So 6.4 times 3.5 is 22.4 feet per second. This part is not asked in the question, but we're just trying to find out everything just for curiosity.